Hey, folks, welcome to our DSS Summit 2022. A lot of exciting conversations and speakers. And today I have with me Nathaniel from Wells Fargo. Well, Nathaniel, I think we've known each other a while. I've had the pleasure of working with you. All conversations with you have been pretty thoughtful and enjoyable. But today we're going to look into Wells Fargo's journey into distributed SQL, right? So maybe, Nathaniel, you'd probably do a better job than me. Can you kick it off with a quick intro about yourself?
Well, sure, Karthik, I'll be happy to do that. And thank you for the time today and the opportunity to speak at the conference. I very much appreciate it. I would say when we first met was a couple of years ago. And at the time, I was the head of technology infrastructure architecture at Wells Fargo. And that includes the entire database technology architecture area. And as we'll discuss in more detail as we go forward, one of the reasons that we came together and got to know each other was Wells Fargo was in the process of looking at the distributed SQL space and ascertaining what was available there and why we would be interested in distributed SQL. And so my role as the head of that segment of architecture at Wells Fargo did involve both innovation and strategy and determining where we might be going in the database technology space. So was really all part of that. Now in the interim, so we've been working together, as you said, for some time now. My role has actually changed from the head of technology infrastructure architecture to a principal engineer role with a specific accountability for database strategy and innovation. So continuing to work in this space very closely and really leading kind of where Wells Fargo is going in terms of database technology, what we are taking out of the estate, what we're evolving within the estate, and what we're looking forward to in coming years. So that's really my point of focus.
Fantastic, and can't think of a better person for the job. So, and I've learned a lot. We've all learned a lot on the Yugabyte side, thanks to you, Nathaniel. So maybe you can kick us off with, why distributed SQL? Why did Wells Fargo feel the need for something like? I mean, you have to have a pain point that leads to a need that leads to things happening. So, what was the need?
We did, absolutely. It was an interesting start to the journey. So there was a colleague of mine at Wells Fargo who for a year or so had been talking to me about kind of what he was characterizing as database grid technologies and the ability to scale horizontally. That was really kind of his vested interest where he was coming from his line of business. So this would have been 2018-ish. I was becoming kind of more aware of the space as something that we needed to understand, start charting into the Wells Fargo strategy. But it was a little bit nascent, right? It was, what should we be doing about this? Let's start thinking about it strategically. And then, as you said, sometimes you have kind of an inflection point, right? A rationale for dramatically accelerating a piece of your strategy. And in our case, it was because we had a pretty significant resiliency issue in one of our data centers that caused a loss in some of our technology portfolio. And so what that manifested in the data layer was a need to, at scale, conduct failover type of events in our database estate. And when I say at scale, it was at pretty significant scale. And we, at Wells Fargo, we run a number of different database products, but certainly the prevalence is still towards your legacy relational database estate, right? Things that have been in the industry for some time, that really still is the largest percentage of things that are being run at Wells Fargo. So when you think about that type of an event and what it means you're doing a lot of failovers. And in a lot of cases, you need a database administrator or a database engineer to sit down and do some of those failovers. So when we were in that situation, there were really two things that became readily apparent while it was going on. The first was, even though you can design a technology solution to achieve everything that you need it to achieve within a given recovery time objective, if you then have to execute that at significant scale, it may be at least temporarily difficult for you to put enough hands on keyboard to get that done. And at the beginning of the event, that might have been kind of the case where it was just we needed to get people available, get them doing the steps that were required to move things from one data center to another. But what also became clear as part of that event was once you kind of got out of that situation, you were still going to have a situation where in these types of active passive recovery scenarios, for a lot of applications, a lot of workloads, somebody had to make a decision to actually move that workload from point A to point B. And so, although for the first couple hours, it was really a matter of rallying people and getting them to the right places, there was more time that was then spent determining if we were going to move something. And this really all came out of the way those database platforms were designed, right? And I think anybody who's a database professional who's been around the industry for a substantial amount of time is really aware that many of our legacy platforms are built with this idea of primary, secondary, and we're going to move from the primary to the secondary. We've got to go over to that replica, and then we've got to recover to that replica, and we've got to repoint everything over there. So that, having to do that on a large scale was definitely one of these inflection points. And we had some specific learnings that really came out of that. So although a lot of our portfolio at the time certainly was what I would characterize as legacy relational database technologies that require you to do that type of a failover, we also had a portfolio and still have a portfolio that's continuing to grow of a non-relational database compute platform that is active in multiple locations. And that particular platform in this particular event survived very well. It proved to be very resilient to have an active platform already deployed to multiple data centers using a singular topology. So again, a lot of the legacy platforms would assert that they can operate in a topology that is active, but it's not centrally managed. It's difficult to fail over in that type of an event, and you
There's
have
also a lot of there's also a lot of understanding, right? Like a lot of scenarios that people kind of assume, right?
there's a lot of complexity, exactly. And so we found that a relatively robust platform didn't require a lot of complexity, was already active, survived this type of event very well, and actually received a lot of complimentary feedback from the consumers of those database platforms within Wells Fargo. And so what we took away from that was we need to have this not just for our non-relational space, but for our relational space too. So that was our premise. There must be something in the industry or something that's being built in the industry that's going to give us that level of resiliency in an event like this. Everything stays up, everything's active. It's a centrally managed topology, relatively robust and simple to deploy, and also gives us a relational platform with ACID compliant transactions. So that was a key inflection point, I think, on our database journey. It really accelerated our interest in distributed SQL. Right after that, we did begin to bring things into lab and look at what the specific industry offerings had and how they would apply to Wells Fargo use cases.
Right. So a couple of just diving into one aspect of this, right? I mean, you said this was getting harder to do. Like, it required people to be trained and people to be available in order to do this failover event, right? Like the legacy architecture I meant, right? And you said it started getting hard to do. Is that because of a combination of things like, because we do hear from all over the place that the number of such applications you have to build starts increasing, or the scale of any particular application starts increasing. And therefore the number of errors you can encounter or the number of such scenarios you have to deal with also starts increasing, right? Would you characterize it that way? Or is this more set yourself up so you can get to a spot where you don't have to worry about each one of these and it starts difficult to handle?
Yeah, I think I would attribute it to three different things. I would say, you might have to remind me of this because I'm speaking off the cuff, but I would say one is having to have some knowledge of a particular point solution. Another is being able to execute a series of manual steps effectively. And then the last would be a centrally managed topology. So all three of those things kind of come into play. Probably the first is one of the ones that we don't speak about a lot, but it is really germane. So when you have an event like that and you're talking about recovering a significant volume of systems, there's always the possibility that one of those systems does something in its runbook a very particular way that is somewhat different from the standard way of doing it. And so then you have to have some specialized expertise to understand the implication to that workload of moving its database around. And the more that you have to do that at scale, as you're alluding to, Karthik, the more complex that gets, right? The more you move away from a standard where everything is relatively simple to a place where you need to have specialized knowledge to execute one of these types of events, that can become more complex, more problematic. I think the other two are a little more well understood, right? The first is you're going to have a relatively standard playbook. In this case, you can't just go press a single button and get a failover to happen, which is what you really want. You might have to go through multiple steps to get there. And in our journey at Wells, we've gone through significant iterations of the evolution of just having orchestration platforms that give you more of that ability to press the button and execute a series of complex steps. But there's still those complex steps that underlie that. And so then if one of them goes wrong, you're back to having to solve a complex problem in the middle of a crisis, which is antithetical to what you're trying to achieve. And then, the centralized topology is another one of these. As you get into solutions that might require you to use three different things. So I can think of one solution that we have where the platform requires you to essentially deploy three different technologies to meet all of the different use cases that might happen during a failure. And they don't all work together. They're not all managed from the same console. And so that needing to manage multiple topologies to get to a solution that just works for every use case is another pretty significant pain point.
Yeah, no, I think even on the sequence of steps point, I think if it starts happening often enough, right? I heard this really sad incident once from somebody, like, so many people that in the database industry, they moved from, one instance type to a newer instance type, and it had to be an online migration. And the ops team was already pretty tired, having dealt with so many issues, that they orchestrated this over 4 days, the move from the source to the destination, had the destination catch up. It was in near real time something. And then something went wrong and people ended up dropping the destination instead of the source. And so, just that one mistake in that last step of which database to remove from this list, right? That means you had to repeat it all over. And now your probability of error goes up even higher. And so, I think it's the being under the gun situation, right? Like when you're trying to do this at scale, it's like humans are not built for that type of stuff, while machines are, right? So,
and if I think any technologist who has been around operations for a period of time is going to have lived through something like this. I've been on that 2 a.m. bridge line.
Yeah, me too.
And working people through it, and it started with the idea that we would script things more, I think, in the industry, right? That we would move to scripting, that we would move to silent command line coupled with scripting, that we would move to orchestration tools that would then kind of package those scripts and all execute them. And I see, what we're looking at in terms of a modern platform as the next evolution of that, to continue that trend of abstracting, at least at the point of execution, all of the steps that have to occur underneath that. Now, clearly, you need a relatively robust testing paradigm to make sure that when you press that button, the things underneath it aren't going to break. But as we look at cloud services, as we look at modernized database platforms, that seems to be what we're all trying to achieve, is to be able to package those things ahead of time, place them in an orchestration layer, invoke them with a relatively simple interface, and then get logging and feedback to make sure that it's been successful.
Makes total sense. Okay, so let's come to where we are now, right? So you determine the need for this, and then you're looking at distributed SQL. What does getting a reasonable adoption currently of distributed SQL look like? Like, what are some of the things you can think of that become important when you think of such a thing?
Yeah, I think one thing that although we talked about that past event a fair bit, spent a bit of time on it, one of the things that I'll also call out as we were looking at the journey into distributed SQL that is probably equally important is the idea of a horizontally scalable system. And we could spend a lot of time talking about the evolution in the database technology and the industry around trying to get to that. Having been around databases for a while, you see a single database on a single node evolving to parallel databases with parallel execution across nodes, to trying to span things with clustering solutions, to reading from standbys. Again, what we are really all in search of is trying to scale in a near linear manner horizontally, so we can bring more things into the solution to get horsepower for our workloads as we need it, or potentially take away from it. And that's another really key thing why we were going into the distributed SQL space. Within our estate, there are, and I would imagine within most people's estates, there are some limits on what is readily available from commodity hardware in terms of a vertical limit. And so then that limits your database. What if you're using single node database solutions, or even things that can scale, but you have to do a lot to scale them. And so we're looking very much at distributed SQL as a way to increase that scalability, putting into it, taking away from it, and ensuring that we have a platform that can still deliver a relational data model and be ACID compliant in terms of its transactions as we're doing that. So that, I would say, those two things in terms of why are we here, right? Resiliency and scalability, both with an aspect of manageability, because those don't do us any good if we can't then manage them, if they're too complex to manage. Absolutely. So carrying that kind of into today, what does that mean to us? And one thing is, being on a journey. I think as we look at the distributed SQL space within the industry, it is a relatively new space. There have been some organizations that have been in for 5 to 7 years, but are still getting to a point of maturity, I think, where you would be able to compare them to some of the legacy relational platforms in terms of feature parity and functionality. And so one of the key aspects of our today's state is making sure that we are co-developing a solution, co-developing a roadmap, because it is a new industry segment. As we look at distributed SQL, what should go into that? What should be prioritized? And for an organization like Wells Fargo, we have some very clear perspectives on that, right? We have a need to manage risk in a very tight manner. We have a need to ensure resiliency. And so, again, working with an organization that is going to be able to co-develop with you that journey to bring feature functionality into the estate as you're taking up the distributed SQL platform, I think that's one key aspect. It's not like you're going and looking at a technology space that has been in operation for 30 years and you're just taking something that's ready out of the box available. You got to go into it with a mindset of, these are my workloads. This is what I need to achieve on behalf of the enterprise that I represent. And how are we going to get there from here with this platform? And a big piece of that is, can we use it, right? So I think when I've had some conversations, right, being around the database innovation space and driving it at Wells Fargo since 2013, so 9 years or so, I've talked to a lot of vendors in my career, and talking to organizations that are trying to bring a product to market, and they are thinking of what they're doing kind of in a first manner. We're trying to bring this to market, and that's the revolutionary thing that is going to change everything, and that's why my particular technology is important. It's good to know that. It's good to be able to advertise that. It's good to be able to talk about it. But at the end of the day, what an organization like Wells Fargo is going to need ultimately is a platform that we can use, not for a niche use case in all likelihood, but at least for a significant portion of our estate. And here, that's even more important because we're talking about a relational platform. Like, why are we going into distributed SQL? It's not just for the newness of distributed SQL. It's because we need a relational platform that is ACID compliant, that will bring enhanced scalability and resiliency to market for our workloads. So stating all of that, we're looking at something that can be a relational database platform for us. The distributed SQL piece, very important and not secondary, but paired with this ultimately would need to be a primary relational database offering for an enterprise the scale of Wells Fargo, which is pretty significant. So it can't be works for 2 workloads. It's got to be works for 2,000 workloads. And so we take a very, I think, pragmatic view of, can we use these distributed SQL technologies to meet that scale of different types of workloads? And in a lot of ways that manifests, to me, kind of the litmus test for that is, for the majority of use cases, could I lift from my legacy platform and bring them to this platform, this new platform, achieve the benefits of doing that, and do that in a relatively low friction manner, something that isn't going to require me to just wholesale rewrite the application and the data layer, because that's not low friction at all. I need to be able to move to a platform that can support the majority of these workloads. So, then we're looking at things that are open source, well understood in the industry, have an interface that developers are going to be familiar with, that our administrators are going to be familiar with. We're going to be able to take up relatively quickly. And it does go back to the roadmap. We've got to, and Karthik, you and I have talked about this, right? The workloads that could go onto a distributed SQL platform, you start from a point of what's a good fit, because distributed SQL carries, depending on how you deploy it, some things that you really need to be aware of, like internode communication when you're executing queries, and how the query optimizer is going to handle that, and ensure that you have an architecture that's going to be able to meet that broad range of workloads that you need to bring to market as somebody who's looking at the enterprise strategy for your database technology.
Absolutely. Yeah. I think that's really well said. It's actually dovetails really well into, for example, our own philosophy of, on day one. And by the way, we were also a vendor that was very excited to bring the innovation that we had done into the market. But yeah, in retrospect, it's actually even more important to think about the adoption path, and not just the adoption path for the first couple of use cases or workloads, but the much larger number behind it, right? That's really what's critical, right? As you exactly said, and our doubling down on the known API path, like reusing Postgres, right? And just making sure it's standard, and us not questioning or thinking about, is this particular Postgres feature a useful one? Is this something that people are still building to? I think that arbitrage is really would have led us down the wrong path. We started that way, and we even started building that way. And I think 6 months later, we said, you know what, this is not converging soon enough. So let's switch to reusing Postgres, and let's just go with the belief that Postgres is what people need, as opposed to a couple of things inside Postgres that we can strip out. And so it just turned out, thank God we made that decision. So,
and I think you make a really good point, right? Because it's here we're talking about bringing distributed SQL to market, but there's going to be a database overlay that sits on that distributed SQL platform, and having it be one that is ubiquitous and well understood in the industry gets you a significant way there towards adoption. People are going to look at that and say, well, this is going to be much easier for me to adopt than another platform that has gone and done something entirely proprietary, and now I'm going to have to learn something entirely new, both from an administrative and a development perspective. So, distributed SQL as a technology classification is giving us particular things, but there's a database that rides on top of that, and we really can't forget that if we're going to be successful. And then, to your point, the feature set that goes within that relatively ubiquitous database, if you come at it from the perspective of what are we going to take forward and what are we not going to take forward, then when you get to the point of adoption, you have to talk with every single person with every single workload. Yes. And that doesn't scale. That doesn't scale.
It doesn't. Yeah. Yeah. I think, makes total sense. Like, so we have a couple of minutes left. So wondering if you can just touch on some of the things in the future. What are the things that you're looking forward to in the evolution of databases and the evolution of database strategy at Wells Fargo? What are the things that you think about?
So two things that I'll talk about a little bit now. Two things I'll talk about just briefly. The first is technology is not technology without people. And when you talk about adoption and bringing a new technology to market within an enterprise like Wells Fargo, it is just as much about having people understand that new technology, how it should be applied, how it fits into the technology strategy, and frankly, getting the development, architecture, administrative operations, the communities of people that you're asking to either design, develop on, or use that platform excited about doing it. And that's really about community. That's about building a groundswell of support within an enterprise. I think it is so frequently overlooked. We go into these situations and we think, I'm going to build a platform. Everybody's just going to come to the platform.
Build it and they shall come.
Exactly. I think a much more successful strategy, or one that I've seen executed successfully, is to go into it with really understanding why we would use that platform, and then talking throughout the organization about that, showing people in live settings how you're doing it, showing people hands-on how and why to use it. So that community, building the technology awareness within people, not just about the technology, I think is one thing that we look forward to doing a lot more of at Wells Fargo. And then the other is, and I alluded to this, our distributed SQL platform as a general purpose platform. So bringing things to it such that it becomes something that is ubiquitous within Wells Fargo and becomes just how we do relational computing within the estate. And that will also be about ensuring that as we go into the future, that platform is going to be usable. So what have legacy relational platforms in the industry done for the last 30 years? They've done a pretty good job of listening to their consumers and then going and building feature functionality within the platform. So any distributed SQL platform, I think, that's going to be successful is, again, going to be about the database that rides on top of the underlying distributed SQL system. Is it getting the right feature functionality to market beyond just the core resiliency, beyond just the scalability? What do we get when we are bringing that database forward? So that could be an in-database thing, like an analytics windowing function that is built into the database itself. It could be considerations about how you deploy it. So ensuring that there's a well-understood architecture for multi-tenancy, getting lots of people onto shared infrastructure and driving up operational efficiency as a result. And it could be something like thinking about how this is going to work in a cloud environment. So when we bring a platform to cloud, it doesn't end at the platform. There are always lots of services around that to couple it to the cloud provider. So how consumable is a cloud security service within the context of the managed database provider? And I think when we put those things together, we start to look at a platform that is not only solid in terms of bringing distributed SQL to market today, but it's something that there's a commitment to continuing to evolve as we go to the next 3, 6, 12 years in the market, maturing it and growing its use.
Fantastic. Yeah, I think looking forward to working with you and with Wells in general on a lot of these things. But these are amazing. These are pretty aligned with a lot of things that we're thinking about also in the evolution of the database. But this is fantastic. Thank you. Thank you for sharing the insights. This was really, really a fantastic conversation, Nathaniel. Thanks a lot.
Absolutely. Thank you, Karthik. Thank you for having me. And it was a real pleasure to speak with you.
You bet.